Welcome to solverfy.
So this question is asking how potassium channel blockers would affect the firing of an action potential. So when we look at an action potential, which shows the change in voltage or membrane potential over time, a general trace looks something like this, with the axon generally depolarizing until it reaches the threshold potential, which I've drawn here with that red line. Once it reaches this threshold potential, sodium channels open and depolarize the membrane. And after it reaches peak depolarization, the potassium channels open and the membrane becomes repolarized and actually hyperpolarizes before it returns back to its steady state. So the point where the potassium channels open is at this peak depolarization and leads to the repolarization of the cell. And since it is repolarizing, that is gaining back its negative charge, and potassium is positively charged, we know that that could only be achieved by the movement of positively charged ions out of the cell. So the directionality of this repolarization is the efflux or exit of potassium ions out of the cell. So the correct answer to this question is B. Repolarization after peak action potential would be affected by potassium channel blockers, because that is the point when potassium begins to leave the cell.